Hi guys, welcome to Easy Math.
In this video, we are going to understand about what are matrices and determinants. First of all, what is meant by matrices? Matrices means it is a arrangement of elements in row wise and column wise. For example, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is called as a matrix where we have arranged elements row wise as well as column wise. This we call it as a first row, second row, third row, and this is called as first column, second column, third column. So arrangement of elements row wise as well as column wise, we call it as matrices. Now if you look at this element we can denote it as A11. A11 means first row, first column. This represents the element in the first row, first column. This means we can represent it as A12 because this 1 represents row, 2 represents column. Then we can represent this as first row, third column. We can represent remaining elements also the same. If I come to this element, I can represent it as 2, 1. This shows that this is second row, first column. A22 means second row, second column. A23 means second row, third column. A31 means third row, first column. A32 means third row, second column. A33 means third row, third column. Always we have to represent row first, next column. Like this only we have to write the order of the matrix also. Order of the matrix means it represents that how many rows and how many columns this matrix has. For an example, if I consider this matrix, I can say the order of the matrix is 3 cross 3. How I am saying it is a 3 cross 3 matrix means because this matrix has 3 rows and 3 columns. Always this represents the rows and this represents the columns. This is called as order of the matrix. Next, we know the order of the matrix. If you look at this matrix, we have an order as 3 cross 3. 3 cross 3, the rows and the columns, if it is equal, then we call it as a square matrix. If the rows and the columns are equal, it might be 2 cross 2 matrix also, it might be 3 cross 3 matrix also, it might be 4 cross 4 matrix also. If the number of rows and the number of the columns are equal, then we call that matrix as a square matrix. And nextly, now we are going to discuss about singular and non-singular matrix. For singular and non-singular matrix, the concept we can discuss only for the square matrix. The concept of singular and non-singular matrix we can discuss only for the square matrix. What is meant by square matrix? If the number of rows and the number of columns are equal, then we call that matrix as a square matrix. Nextly, let me tell you how to find the determinant if it comes to a 2 cross 2 matrix as well as to the 3 cross 3 matrix. Why? Because using determinant only we can discuss about singular and non-singular. Okay, I will consider one 2 cross 2 matrix 2, 1, 3, 1. This is a 2 cross 2 matrix. I am considering this matrix as A. So, one row, second row, one column, second column. The order is equal, which is 2 cross 2, then it is said to be a square matrix. If I want to find the determinant, how to find the determinant means we have to multiply this diagonal first. 2 into 1, 2. Next, by default we will have one negative symbol. 3 into 1 is 3, which is nothing but minus 1. This is how we will find a determinant when it comes to a 2 cross 2 matrix. And now I will explain you how to find a determinant for 3 cross 3 matrix. I will take one example. Next, we will find a determinant for 3 cross 3 matrix. Let us see how to find out. I will consider an example. Just an example. Okay. So, now we are going to find a determinant for 3 cross 3 matrix. Next. So, we can either go row wise or column wise also. It is of our wish. I will follow row wise. For example, if I am going to consider this one, I have to eliminate the column which is touching this one and eliminate the row which is touching this one. So, this will be eliminated. The submatrix will be this one, 1, 3, 5, 6. So, we have to find the determinant, like we have to multiply this diagonal minus this diagonal minus alternative symbol obviously will have a minus. So, this is default minus 2. If I am going to find this submatrix for this number, I have to eliminate this column and this row. So, remaining will be 6 2s are 12 minus 4 3s are 12 plus 3 into, if I am going to find for this element, I have to eliminate the column which is touching this number and eliminate the row which is touching that number 3. So, the remaining submatrix will be this, 5 2s are 10 minus 4. So, my answer would be 1 into minus 9 minus 2 into 0 plus 3 into 6 minus 9 minus 0 plus 18. So, 18 minus 9 is 9. Determinant of A equals to 9. So, this is how we find the determinant of A for 3 cross 3 matrix. Why I discussed about the concept determinant now means because we are going to discuss about singular matrix and non-singular matrix. We are going to discuss about singular and non-singular matrix. So simple. We will consider the previous example itself. For this matrix A, we found the determinant. If this determinant value, if it is not equals to 0, then we call that matrix as a non-singular matrix. If the determinant value, if it is not equals to 0, then we call that matrix as a non-singular matrix. Similarly, if you consider any example, I will consider one 2 cross 2 example. So, similarly, I am considering this matrix. I will consider this matrix as A and I will find the determinant for this matrix A. So, how to find 0 minus 0? If you look at this, the determinant of A, we got the value as 0. Then it is said to be a singular matrix. So, we can easily say that if the determinant value not equals to 0, then we call that as a non-singular matrix. If the determinant value, if it is equals to 0, then we call that as a singular matrix. Okay. Next is inverse matrix. We can find only inverse when the non-singular matrix, when we have the matrix as a non-singular matrix. For example, I will take A inverse. If I wanted to find the inverse of some matrix which I have considered it as A, the formula for finding this is 1 by determinant of A into adjoint A. So, determinant A, if it is not equals to 0, then we call it is called as a non-singular matrix. Only for the non-singular matrix we can find the value of A inverse, because if the determinant value not equals to 0 means only we can find the value. You itself consider if the determinant value, if it is equals to 0 means anything divided by 0 will lead us to infinity. We cannot find the inverse value if the determinant of A is a singular matrix, that is determinant of A, if it is equals to 0, then we cannot find the inverse value. Always inverse matrix is applicable only for the non-singular matrix. So, the A inverse formula is 1 by determinant of A into adjoint of A. Next, let me give a brief explanation how to find the adjoint of A. Okay. Let us consider a matrix A. Find adjoint of A. So, I will consider one matrix, 2 cross 2 matrix, 1, 2, 3, minus 4. If I wanted to find the adjoint for 2 cross 2 matrix, how to do that is, this diagonal wise we have to swap the elements, that is minus 4 has to come here, 1 has to come here. This diagonal wise we have to swap the elements, whereas this diagonal wise we have to change the sign of an elements. This has plus, so we have to change it as minus 2. This has also plus sign, we have to change it as minus 3. This is how we have to find the adjoint if it comes to a 2 cross 2 matrix. Next, similarly, we will see how to find an adjoint for 3 cross 3 matrix. For the, I consider the matrix A equals to, in general I will consider this element we represent it as A11, this element we represent it as A12, A13, A21, A22, A23, A31, A32, A33. So this is how we'll have the matrix. I have considered 3 cross 3 matrix. Now for finding adjoint A, we have to write the minus for all the terms. Let us now understand how to write the minus. For example, if I am going to write for this term, I have to eliminate the column which is touching that term and row touching that term. So the submatrix will be A22, A23, A32, A33. So this is the minor for the first term, and alternative terms will have minus. Easily we can remember this diamond shape, you people can remember. These terms will have default negative symbol. If I am going to consider A12, I have to eliminate this column and this row. So I will get A21, A23, A31, A33. And for the third term, I will write the minor. If I am going to write the minor for this term, I have to consider this submatrix A21, A22, A31, A32. Next, this term will have minus, so default minus. So we have to eliminate this row and this column. A12, A13, A32, A33. Next, we form this term. So if I consider that, I will get it A11, A13, A31, A33, and this term will have minus by default. So we are putting minus over here. The terms within that will be A12, A11, A12, A31, A32. Next, for this I am going to write the minor. For this if I write, I will get A12, A13, A22, A23. Alternatives will have minus. So minus over here, we will get it as A11, A13, A21, A23. Next, for last term, A11, A12, A21, A22. After complete solving this, we have to take the transpose. That will be the answer for your adjoint of A. This is how we have to find the adjoint of A.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.